Continuing with rate of change, we have this word problem. So the word problem stated, a delivery truck is transporting clothing supplies. 30 minutes from the beginning of the trip, the truck traveled 45 miles. 2 hours and 30 minutes from the start of the trip, the truck traveled 185 miles. Now this question, what is the rate of change miles per hour? So let me underline that. Miles per hour. So the change of y over the change of x, basically change of miles over change of hour. So we're going to be working in hours. Now the one thing we have to watch out is, if we look at the problem, the first part, it says 30 minutes. This is in minutes, but not in hours. And then the second part here, 2 hours and 30 minutes. Even though it has hours, it actually has minutes. So if you're given in minutes, but it's asking you in hours, you can still convert minutes into hours. So for example, 30 minutes is the same thing as 0.5 hour. Now 30 minutes is half of 60 minutes, and a full hour is considered 60 minutes. So if you are given 30 minutes, you're just given half of the hour. So repeat, a full hour has 60 minutes. Now if you only have 30 minutes, that's basically half an hour, or 0.5. Now 2 hours and 30 minutes is the same thing as 2.5 hour. So basically we just convert 30 minutes into hours. 2 hours and 30 minutes equals 2.5 hours. So now we're going to find the rate of change. So my change of miles, what we're going to do is we're going to start with the latest. Now sometimes it helps me if you write it in coordinate points. So for example, our first one was 30 minutes and 45 miles. So I'm going to use 0.5 in terms of hours and then 45 miles. And then the second one, 2 hours and 30 minutes, I'm going to use 2.5 hour and it travel at 105 miles. So here I can label my x1, y1, x2, y2. So for our change of miles, I will start with the latest, so 185 miles minus the beginning miles, which is 45, over our hour. So since I started with 185, I'm going to start with 2.5 minus, since the 45 came second, I'm going to write 0.5. Alright, so we're going to work out the top. 185 minus 45, that's simply 140. 2.5 minus 0.5, that's going to be 2.0. It's the same thing as 140 over 2. So 140 divided by 2 is 70. So my final answer will be 70 miles per hour, or mph. So that's going to be my final answer. I'm going to box that up. So this is the work you would have to do, thinking logically about how to convert minutes into hour. So 30 minutes, 0.5 hour, meaning a half an hour. 2 hours and 30 minutes, the same thing as 2.5 hour. So I was able to work in terms of hours to get 140 over 2, which will equal to 70 miles per hour. I'm using the same word problem, but now the question is, what is the rate of change miles per minute? So let me underline that. Miles per minute. So my change of y over my change of x is equal to change in miles over change in minutes. Right. Now, in the previous part, we converted minutes into hours. Now we're going to convert hours into minutes. So the only thing we have to worry about is this part right here. So we know that 1 hour consists of 60 minutes. And then 2 hours is basically 120 minutes. So 2 hours and 30 minutes if you were to combine. So 2 hours, that's 120, combined with 30. So we could say that 2.5 hour is equal to 150 minutes. So 2 hours is 120 plus 30, 150 minutes. Alright, so going off on this, change in miles. Now, like I did before, I'm going to write out my coordinate points. So at 30 minutes, the truck traveled at 45 miles. At 150 minutes, the truck traveled, 185 miles. So there's my coordinate point. Now you can do the same thing as before, x1, y1, x2, y2, and you set it up just like the formula that we did in the previous part. So my change of y, change in miles, over my change of x, change in minutes. So again, I could start with the latest, or I could start with the earliest. So say I did 45 miles. And then I'm going to subtract with 185 over, since I did with the 45 miles first, I'm going to put 30 for the minutes, subtract, and then 185 miles was the second part. I'm going to use the 150 for the second part in the denominator. So on the top, 45 minus 185 will be negative 140 over 30 minus 150 will be also negative 120. So you can actually simplify that. Negative 120 and negative 140 over negative 120. Well, since negative on the top and the bottom, the final answer would be a positive answer. Now 140 and 120 can both be simplified, being divided by 20. When I divide by 20, it will equal to 7 over 6. So you're going to leave it as a fraction. Basically, it's going to be miles per minute. So I'm going to just leave it as a fraction. Don't worry about converting to a decimal unless I ask you to convert into a decimal. And if you do have to convert in decimal, you just use long division. But for the time being, just leave it as a fraction. 7 over 6 miles per minute. So that's what you have to do. It's similar but going in the opposite direction of the process that you did in the previous part. So just using logical thinking, 1 hour is 60 minutes, 2 hours is 120, therefore 2.5 hour is 150 minutes. And the order that you use, which one you use first and which one you use second, does not matter. Here I use 45 miles first and then 185, Therefore, I use the 30 minutes first and 150 second. You come out as negative on the numerator and on the denominator, but your answer still come out as a positive answer, which is a good thing. So again, it doesn't matter what order you start off, as long as you follow the same order on the top and on the bottom, your answer should come out as positive. Unless specifies if there's something that's being increased or something that's being decreased, then the sign of the answer might varies. So just be very careful with your order. Make sure your label work correctly. And this is, again, it's okay to have fraction in your answer as long as it does not ask you to convert into decimal. If it does, then you must convert into decimal.